Okay, good morning, everyone. So we have done trigonometric ratios of 0 degree and 90 degree. I think we haven't completed the trigonometric ratios of 0 degree, right? I think we have completed this one. What you have to focus is what are the values of sine 0? Sine 0 is 0, cos 0 is 1, tan 0 is 0, cosec 0 is infinity, sec 0 is 1, cot 0 is infinity. So sometimes this infinity sign here, they can be written as indeterminate. Okay, indeterminate, there is no such values in mathematics up to your level actually. So you can say that indeterminate or undefined value in case you obtain infinity, okay? But understand what's the value of sine 0, cos 0, tan 0, cosec 0, sec 0, cot 0. You remember these three? Take the reciprocal of the rest. For the rest, sine and cosec, they are reciprocal of each other. Cos and sec, they are reciprocal of each other. Tan and cot, they are reciprocal of each other. So once you get 0 here, the reciprocal of sine is cosec, right? So for cosec 0 degree, you have to just write 1 by sine 0 degree, as I'm doing right here. Okay, once 0 degree is done, let's do for 90 degree. Okay, let's do 90 degree. I'm rubbing everything off. So let's rub it off first. Okay, and everyone, I think you must have remember, you all should remember that some of her, that small sentence there for you to remember. Some of our children are having trouble over algebra. This sentence you have to remember absolutely. This represent the portion for sine. This represent the portion for cos. This represent the portion for tan. So I'm keeping this on the side so that you will be able to remember it easily for future reference also. I'm keeping them part by part. Okay. Okay, so whenever we want to know what's the formula for sine, cos, tan, you just refer on this side. Okay, now let's come to what is the value of sine, cos, tan, and the other three remaining in case the angle is 90 degree. All right. So consider one moment. What we are doing here is we are considering this angle to be theta. So this is the opposite, this is the adjacent, this is the hypotenuse. Hypotenuse is fixed, opposite and adjacent, they will change according to where you keep the value of angle theta. If I take the angle theta here, opposite will be okay. I think you should have do a thorough revision. Trigonometry being a new concept, it will be slightly difficult for you. Once you are handy, it will be very easy. Okay, so don't make it a difficult topic. Make it a difficult topic. Don't make it a difficult topic. It's up to you. It's up to how much practice you keep, how much study you do. So if I want to make this angle 90 degree, so look, if I increase this angle theta, this is not exactly 90 degree. 90 degree looks like this, right? This is 90 degree. So I have to increase this angle theta in order that I have to increase this angle theta in order to reach 90 degree. What I want you all to do is I want you all to focus on what is happening to the opposite side. If I increase the angle theta slightly, the opposite side, it increases. If I increase it further, the opposite side increases. If I increase it further, the opposite side increases. Still, at the biggest one that I'm drawing here, the angle is still not 90 degree. So if I want 90 degree, I have to draw like this. These two, they will not meet. But you know that on increasing this angle theta, this opposite side is going to increase considerably. Adjacent side doesn't change. Hypotenuse, it also becomes a very large value, right? So like let's say I increase the angle up to here. Hypotenuse, the hypotenuse also increases, opposite also increases. So what is going to happen is if I want angle theta like this, if I want the theta to be 90 degree, this opposite side will be very long, the hypotenuse will be very long. All right. So remember what is the formula for sine theta? For sine theta, it's opposite divided by hypotenuse, right? So if I make the angle 90 degree, you can assume that hypotenuse is equal to opposite side. What will happen then if hypotenuse and opposite side are equal? If we found out the value of sine theta, theta is how much? We are taking it to be 90 degree. So for sine 90 degree, what we are having is the formula is opposite by hypotenuse. I just told you opposite will be very long. So also the hypotenuse will be very long. They will be very, very long, and they will be almost equal. If we divide two values which have similar values, like let's say if we are dividing 1 by 1 or 2 by 2, if we are dividing two equal number, what do we obtain? We will obtain 1. And then what about cos? Cos 90 degree. What's the formula for cos? You look here, adjacent by hypotenuse. Adjacent, it remains the same, right? But the hypotenuse is very long. Adjacent is, let's say it's 2. Adjacent is, let's say it's 2. Hypotenuse is very, very long. You cannot take numbers 4, 5, 6, or 10. You have to take a very large number in terms of 10,000. So we can write infinity here. 2 divided by a very large number, it is almost equal to 0. So you should know that the value of cos 90 degree, it's, you have to take an adjacent here. Adjacent divided by a very large value, so cos 90 will be how much? 0 degree. What about tan 90? The formula for tan is what? The formula for tan is opposite divided by adjacent. What's the opposite? Opposite is very large. I told you already, right? If theta increases, then opposite becomes very large. You can consider the opposite to be infinity. Divided by adjacent is how much? Adjacent, it remains the same. It doesn't change when we change this angle theta right here, isn't it? So adjacent, you can just keep it here. Infinity divided by any adjacent number, that will be how much? It will be an infinity value. So sine 90 degree, how much is it? This is 1. Sine 90 is 1. Cos 90 is 0. Tan 90 is how much? Infinity. What about the rest of them? There are 3 more remaining, right? Cosec, sec, and cos. So in case of cosec, what you have to do is, you have to, if I want cosec 90 degree, what I have to do is I have to write 1 by sine 90 degree. It's the reciprocal, okay? So 1 by sine 90 degrees, how much? 1 by 1, so we will get 1. Cosec 90 degrees, 1. What about the what about the sec 90 degree? Sec 90 is the reciprocal of what? Sec is the reciprocal of what? It's the reciprocal of cos. So sec 90 will be, we will have 1 by cos 90 degree. How much is cos 90 degree? I'm writing 0 here, right? So you put 0 here. 1 divided by 0, or if you divide any number by 0, you will get infinity. So sec 90 is infinity. What about tan 90? Tan 90 will, what about cot 90? Cot 90 is the reciprocal of tan. So we will have 1 by tan 90 is infinity. If 1 is divided by a very large number, tan 90 is how much? Infinity. Infinity just means that the number is very large, okay? If 1 is divided by a very large number, we are going to obtain 0. So you can write down the number on the side. You can write down the values on the side. You just say here, when theta is equal to 90 degree, then opposite side and hypotenuse becomes very large. So we will have, what's the value of sine 90? Sine 90 will be, sorry. So sine 90, it's opposite by adjacent. The value of opposite side is very large. Okay, sorry, it's not adjacent. It has to be hypotenuse, right? The value of opposite is very large. Hypotenuse is very large, but we are dividing large by large. So similar value, we are going to obtain 1. And then cos 90 degree, what's the formula? Look, the formula for cos is here, adjacent divided by hypotenuse, isn't it? So if you write adjacent by hypotenuse, adjacent remains the same, remember, but hypotenuse, since it is very large, a constant number divided by a very large number, you can consider it to be 0. 1090, we will have opposite divided by adjacent. Opposite side is very large already, adjacent is a small number compared to the opposite side, so we will have infinity here. And then I'm writing the reciprocals on the side also. You copy this when I'm writing. So any number divided by infinity is 0. You should know that, okay? Why I'm writing 1 by 1, 1 by 0, 1 by infinity is because cosec is the reciprocal of sine. That's why I'm writing this as reciprocal. When you write reciprocal, you have to write 1 by something value, right? Sec is the reciprocal of this number right here. So we have to write 1 by 0. That's why I'm writing 1 by 0. You don't need to remember this, actually. What I want you all to remember is what's the value of sine 90, cos 90, and tan 90, as well as what's the value of 0 degree. We have already done in the previous class, right? So you copy this quickly. I'll give you all 2 minutes. After that, we will move on to what happened if I change this 90 degree into 45 degree. If I put 45 degree here, 45 degree here, 45 degree here, 45 degree in everything, then we will try to determine what will be the values. Okay, quickly, 2 minutes.
Sir, they have finished copying, I think. You can carry on.
Okay, sir, moving on. So next comes our trigonometric ratios of 45 degree. This one we can easily draw in a right angle triangle. All right. Look, right angle triangle. The previous one, it's not possible to draw 0 degree or 90 degree in a right angle triangle. Why? Because if one is made 90 degree, the other one is made 0 degree. This one will become 90 degree because if I add the three of them, we will get 180. It's not possible to draw 0 degree. In that case, we are not going to get a right angle triangle or any triangle for that matter. We are just going to get two lines like this if we want 0 degree. So we made assumptions. But if the angles are 45, 30, 60, for these three cases, we can draw it in a triangle. Let's see. So I'm drawing a triangle. I'm drawing a right angle triangle. So in this right angle triangle, if I make one of them right angle triangle, one of them, one of the angles should be 90 degree, right? So one of the angles is 90 degree right here. Sir, please wait a minute. So if I make one of the angles 45 degree, what will be the other? The other one will also be 45 degree. Remember? Because if I add 1, 2, 3, the three of them we are supposed to get 180 degree because it's a right angle triangle, isn't it? No, it's a triangle. For a triangle, the sum of all the angles should be how much? 90 degree, 180 degree. What we can see here is if I make one of the angles as 45, the others is also 45 degree. Okay, so according to the rule of a triangle, there was a theorem like this. If the two angles are equal, if these two angles are equal, then the two opposite sides, they will also be equal. If I make these to be 30 degree and 30 degree, this side and this side, they will be equal. If I make this 4 centimeter, the other one will also be 4 centimeter. You can make any other angle, okay? You can make these two to be 60 degree. Still, if the two angles are equal, the sides opposite to these angles, okay? You cannot have these two sides equal. Specifically, if the two sides of a triangle are equal, the sides opposite to the angles, they will be equal. So you keeping that in mind, keeping this theorem that you have already learned, I think it was in class 8. So keeping that in mind, here we have got two angles which are equal, right? What's the angle, what's the side opposite to this? Let me name this. This is A, this is B, this is C. What's the side opposite to this 45 degree? Right here. What's the side opposite to this 45 degree? Right here. So side opposite to this angle A is BC. Side opposite to the other one, side opposite to the other 45 degree is this AB. So according to the theorem that I just said, AB will be equal to BC. So if I put, I don't know what are the values of this, what is the length of this AB, what is the length of this BC. But since the two angles are equal, these two sides must also be equal. Let me keep AB as side A. A. The length of this AB is A. Length of this BC is also A. What about the hypotenuse then? This is a right angle triangle. If two of them are known, the other can be determined very easily, isn't it? By using Pythagoras theorem. So what will be the length of the other one? Length of the hypotenuse. I can use Pythagoras theorem. Pythagoras theorem will look like this. Hypotenuse square is equal to sum of the two remaining. The length of AB, we have taken it as A. Length of BC, we have taken it as A also. Why are we making these two equal? Because these two angles are equal. So this is A square. This is also A square. If I add A square and A square, I am supposed to get twice A square, right? Find out the AC. We will have root over 2A square. Separate the square root. Root over 2 into root over A square. I can cancel the square and root for the root over A square. This one I cannot cancel. I cannot do anything. I just have to keep it as it is. So the remaining value is the value of the hypotenuse we obtain is root 2A. So I have drawn a right angle triangle. I have made the two angles 45-degree. In that case, the two sides are equal. Now, how much is the hypotenuse? Hypotenuse is root over 2A. Let's just keep it. What about we find out the sine 45, cos 45, tan 45, those things? If I want to find them out, you can take any of the angle. Both of them are 45, right? If I take this angle as theta, I'm taking this angle C as theta. What's the opposite now? Opposite will be this side right here. AB is the opposite. What's the adjacent? Adjacent is this one. So I'm writing them also. This is the adjacent. Sorry. This is the opposite. This is the adjacent. If I want sine 45 degree, if I want sine 45 degree, you don't copy this right now. Okay, I'm not giving the notes in a proper manner. I'm just trying to show you what we will obtain as sine 45, cos 45, and those stuffs. Sine 45 degree, what's the formula for sine? It's sum of her, remember, it's opposite divided by hypotenuse. So sine 45 degree will be opposite by hypotenuse. Which one is the opposite? Opposite is this one, AB, right? So I'm writing AB here, divided by, what's the hypotenuse? Hypotenuse is AC. You put in the values. How long is AB? We have taken AB to be A, and we have determined that the value of AC, the hypotenuse, is root over 2A, right? So just put in the value now. We will have A divided by root over 2A. I can cancel out the A and A. What is remaining? 1 by 2. Simple. What about cos 45? Cos is children are having adjacent divided by hypotenuse. So adjacent is how much? Which one is the adjacent? BC is the adjacent, right? You focus on what I'm highlighting here. This is the adjacent. BC is the adjacent. By hypotenuse is, as usual, it's AC. You put in the value. BC is also A. I'm putting A here divided by AC. What about AC? AC is root over 2A. So keep the value. Again, cancel out A and A. So in this case, we are obtaining the same value for cos 45 and sine 45. We are obtaining the same. Let's just put this on the side. What about tan 45 then? Okay, once you know the opposite, adjacent, and then the hypotenuse, finding out the value, it's essentially done already. So what about tan 45? Tan 45, the formula is what? Trouble over algebra, right? TOA, trouble over algebra. So opposite divided by adjacent. What's the opposite? Opposite is AB, adjacent is BC. So just write down it's AB by BC. If you put in the value of AB, how long is AB? AB is A. BC is also A, right? So just put in the value A divided by A. I can cancel them out. So the final value I'm supposed to obtain is 1, right? Okay. So if I want the value of sine 45, cos 45, tan 45, what I have to do is I have to draw a right angle triangle, make one of the angle to be 45 degree. Once you make one of the angle to be 45 degree, the other will automatically become 45. This is because of the property of a triangle, right? And since if two angles of a triangle are equal, their opposite sides, they will also have equal length. That's why we took A. And then once two sides of a right angle triangle are known, we determine it using the Pythagoras theorem and we obtain root 2A. So out of the two 45 degrees, I took one of them to be theta. If I take this one to be theta, this is the opposite, this is the adjacent, and we determine what's the value of sine, cos, tan by using the opposite by adjacent, opposite by hypotenuse, adjacent by hypotenuse, and opposite by adjacent form. Okay, time for you to copy. I'm giving proper notes now. This is asked in your board exam for 3 marks. Okay, so this is an important topic for you. So just write down. You can start copying now. Okay, you know the Pythagoras theorem, right? Hypotenuse square is equal to square of this is equal to square of the sum of these two. Okay, now we don't have to write opposite by hypotenuse anymore. We have already know this, I presume. You know that you can find out the others, right? So that will be your assignment. After this, you try to follow what's the value of cosec 45. Cosec 45 means you have to take reciprocal of the sine 45. This is 1 by root 2 right here. Take reciprocal, it will become root 2 by 1, isn't it? You have to just turn it upside down. Root 2 by 1, you can just keep root 2. And similar thing for sec. In case you want to find out sec 45, you have to take reciprocal of this. So turn this upside down, we will get root 2 by 1 again. So this is root 2. Tan 45, the reciprocal is cot 45 degree. So reciprocal of 1, we will get 1. Same thing. So 45 degree, this is one of the easiest value to remember. Both of them, sine 45 and cos 45, both of them will be equal 1 by root 2, 1 by root 2 each. And then tan 45, you just have to know that this is 1. The others are reciprocal, simple and easy. So just for writing this, you are going to get 3 marks. I mean, you have to continue the others also. Cosec, sec, then cot, all of them, you have to write it down. Okay, so 1-2 minutes. I'm going to wait until 9:11. Okay.
And then you can tell sir whether you have right. But first you ask your friends whether they in the next room. Next room, go and ask them. Ask everyone. They finish writing. Same process every time. Sorry, I finished copying.
Okay, okay. Moving on. Next one. This one, we are taking the angle theta to be 30 degree. And the other one, we are taking it to be 60 degree. Also, very important topic. This one also, it is asked separately for 3 marks each. Okay. So it is difficult to draw a right angle triangle, set it 30 exact, and then determine what are the sides. Okay, you can make any of the triangles here. This one, I can make this much size to be this 30 degree here, 60 degree here, 30 degree here. This one will be automatically 90 degree. The easiest approach in order to find out the trigonometric ratio of 30 degree and 60 degree is you have to draw an equilateral triangle. All right. So for this process, in order to find out what is sine 30 or sine 60, cos 30, cos 60, tan 30, tan 60, we have to draw what? We have to draw an equilateral triangle. Why do we prefer equilateral triangle? Is equilateral triangle, all the angles are 60 degree, right? The 3 angles are 60 degree, isn't it? But we don't have 90 degree. You will say that we are doing the sine, cos, tan from a right angle triangle. Equilateral triangle is not a right angle triangle. You will say something like that. But see here, if I do a right angle triangle, what's the property of a right angle triangle? All sides are equal, all angles are 60 degree, isn't it? So I'm drawing an equilateral triangle A, B, C. Property is all angles are 60 and all the sides are equal. This side is equal to this side. AB is equal to BC. BC is equal to AC. Since all the sides are equal, I'm taking all of them to be A, A. I cannot take A here, B here, C here. Why? Because this is a right angle triangle. All the sides are supposed to be equal. And these angles are how much? 60 degree, 60 degree, 60 degree. I cannot find out what's the value of tan 60 or sine 60 or cos 60 from here. Why? Because this is not a right angle triangle. How do we make a right angle triangle? What you have to do is you just have to draw a perpendicular line to the BC side. Let's name it D. Okay, let's name it D. So this we will call it as altitude because we have drawn it as perpendicular to this side BC. The altitude will also be a median and this will also be an angle bisector. What are these? In case you don't understand, altitude is something that is perpendicular to a opposite side. From one vertex of a triangle, if you draw a perpendicular line to the opposite side, then this line we will call it as altitude. What is a median then? I'm drawing an irregular triangle. A median is a line in which from this vertex, from this point right here, if you let's say this is A, B, C. From C, if I draw a line like this, let's say this is D. And what's the property of this CD line is you divide the AB into two equal parts. The AB was, let's say, 10 centimeter. If I divide it into two equal parts, one of them will be 5, the other one will also become 5, right? So in that case, this line CD, we will call it as median. The median is something in which it divides the opposite side into two equal parts. Altitude is something that is perpendicular to the opposite side. And what is angle bisector? We have an angle here, right? How much is this angle? According to the figure we are drawing an equilateral triangle. So this is 60. 60 divided into two parts, equal parts, 30 degree and 30 degree. If you have any angle, let it be 90 or 70 or 60, whatever angle it is. If I divide the angle into two equal parts using a line like this, let's say this is previously it was 90 degree, I divided into 45, 45. Then this line right here, this is called as angle bisector. What you have to understand is if we have an equilateral triangle, this line is the altitude, this line is also the median, and this line is also the angle bisector. What are the meanings? Altitude means it should be perpendicular. Median means it divides the BC into two equal parts. And angle bisector means it divides this angle right here into two equal values. How much is angle length? It's 60 degree because it's an equilateral triangle. So if we divide 60 degree into two equal parts, we will have 30 here, 30 here. So when you draw the AD, it does three things. First thing is it is perpendicular to BC. Second thing is it divides this angle A into two equal parts. So we have got 30 degree on one side. The others, they still remain 60 degree, okay, because it's an equilateral triangle. And one more thing, how much was the length of this? We have said this is A, right? The A will be divided into two equal parts by this point BD. This is one part, this is one part, both are equal. If this whole thing is A, then this portion right here, if you divide it into two parts, we will got A by 2 here. This portion right here, this will also be A by 2. So let's not write the length of this whole portion as A. I will write this portion to be A by 2, this portion to be A by 2. How much is the total of A by 2 and A by 2? We will get A, right? So how much is BD? BD is how much? This is A by 2. How much is DC? DC is also A by 2. I'm not writing A anymore. Okay, so this is 90 degree. Remember what we started from? We started with a right angle triangle. Then we draw a perpendicular line. The perpendicular line divided it into two triangles, two right angle triangles. What about the sides? This side is how much long? This side is A long. This side is also A long. What about this? This is A, but it is divided into two parts. This is A by 2. This is A by 2. We don't know how long this is, right? What is the length of this AD? We don't know. We have to find it out using Pythagoras theorem. Where do we apply the Pythagoras theorem? We will apply Pythagoras theorem in this triangle or this triangle. Okay, let's start giving you all the notes. In order to find out trigonometric ratios of 30 and 60, what do we start with? Let ABC be an equilateral triangle. In this equilateral triangle, angle A, angle B, angle C, they are all 60-degree. AB, BC, and CA, they have all similar length. You can start copying to save time. And then what we do is we draw this red line right here, AD. How do we draw it? We draw it perpendicular to BC. We draw AD perpendicular to BC. So what AD do further? AD do further, I just told you all already, right? So AD does, it divides this angle into two parts, this side into two parts. AD is also the angle bisector of angle A. AD is also the median of BC. So you can say this angle is how much? 60 is divided into 2, so this is 30 degree. Angle BAD is 90 degree. Sorry, 30 degree. And how long is BD and DC? BD and DC, it has been divided into two equal parts, A by 2, A by 2 each. What is our goal now? Our goal is to find out sine 30, cos 30, tan 30. And then we also want to find out sine 60, cos 60, and tan 60. Just focus on the three of them, right? As I've been saying, just focus on the three of them. The remaining three, cosec, sec, and cot, you just remember them as the reciprocal. Okay, now I'm not taking the whole triangle. I'm removing most parts. Okay, I'm removing half of it. I'm just taking this triangle right here. I'm not taking the whole thing. You draw it, you draw the figure, okay? You don't draw this portion right here. But for the sake of convenience, so that you will be able to understand easily, I'm taking only the half part. Okay, I think you all finished drawing the diagram. I'm rubbing it off. I'm not rubbing everything else. I'm just rubbing small parts, half of it. You don't need to write 90 degree, right? Because you know this is 90 degree. So you take this triangle, you take this triangle ABD. One of the angle is 30, one of the angle is 60. And this angle D is how much? 90 degree. What are the lengths? AB is A, BD is A by 2. We have an issue. We don't know AD. So find it out by Pythagoras theorem. By Pythagoras theorem, in which triangle? In triangle, which one? ABD. Which one is the hypotenuse? This is the hypotenuse, right? AB square is equal to AD square plus BD square. We know AB, we know BD, but we don't know AD. So we have to find this out. Take this to the other side. AB square minus BD square is equal to AD square. Okay, I'm continuing it on the side. Put in the values. What's the value of AB? AB is A. What about BD? BD is A by 2. So right here, A square minus A by 2 whole square is equal to AD square. Okay, look, this is just simple subtraction. I think you will be understand. You will be able to understand very easily. AB we put it as A, BD we put it as A by 2. Because there are squares, we have to open the square. A square remains the same. A by 2 whole square. Square for A, square for 2. So we get A square and 4. So you take LCM for 1 and 4. We got 4 here. Cross multiply 4A square, cross multiply A square. This is simple subtraction, right? So I change the side, I put AD here, and 4A square minus A square is how much? 3A square. The denominator is 4 right here. So final value is 3A square by 4. There is one more thing you need to do. You need to find out AD. That means the square has to go to the other side. It will turn into what? It will turn into square root. Okay. I'm rubbing off small portions of this, not whole. I'm rubbing off until here. If you haven't finished, you can just say you haven't finished up to here. Okay, I can just get it back. Okay, so If you haven't finished, just say. Okay, I'm continuing this portion right here. All right. AD is equal to square root 3a square by 4. You separate the square for everything. You separate the square for 3a square 4. I'm going to get root 3, root a square, root 4. Root 3, it will remain as it is. The square and root here can be cancelled out, right? Root over 4 is how much? This is root over 2 square. You cancel the square and root. I'm going to get 2. So finally, the value that I'm going to get is root over 3 by 2a. We know that AB is how much? It's A. We know that this BD is A by 2. But this one, this AD, we found it out by using Pythagoras theorem. So finally, the value here will be root 3 by 2. Okay, finish copying quickly. We're going to find out, since we know all the sides, 1, 2, 3, we can find out the value of sine 30, cos 30, tan 30. We can find out all of them. I'm rubbing this off also. If you haven't finished up to here, just say okay. Just inform me when you're finished, okay? When you all are finished.
So we are finished.
Okay. Now time to find out sine 30, cos 30, and tan 30. Look at this triangle. We have got 30° here, 60° here. So simple. If I want to find out sine 30, you have to take this angle as the theta. If you want to find out sine 60, cos 60, tan 60, you have to take this angle. All right. But we want 30° first. If I want 30° first, what is the opposite? Opposite is this one. BD will be the opposite. What is the adjacent? Adjacent is this one. So if I consider 30°, I'm going to surround it. If I want 30°, this is the adjacent and this is the opposite. Right. So this is the opposite side if we consider 30, and this is the adjacent side. Remember, if I take 60°, this will be opposite and this will be adjacent. It will be changed. But if I take 30, this is the adjacent, this is the opposite. So find out sine 30°. What are we going to get? Sine 30, remember the formula is opposite by hypotenuse. What is opposite here? Opposite is BD. Hypotenuse is AB. Hypotenuse is the one that is opposite to 90°, right? So BD is how much? BD is A by 2. Better write with 2. By. What about AB? How long is AB? AB is A. You can cancel. You get very confused when there are 3 levels of division. Let me clarify that. A by 2 is divided by A. I can write like this. A by 2 is divided by A. A by 2, if I write multiplication instead of division, if I change it, the A value here, it will be reciprocal, right? We will have 1 by A. A and A got cancelled. What is remaining? We will get 1 by 2. In short, I can write like this. A and A got cancelled. What is the numerator remaining? Numerator remaining is 1 here, by 2 here, divided by 1 here. A number divided by 1, it is still the same. So we will get how much? We will get half. What about cos 30? Cos 30 is adjacent by hypotenuse. Which one is the adjacent? Adjacent, I have just written it. Adjacent is this one. So adjacent is AD divided by hypotenuse AB. AD is how much? Root over 3 by 2A. Then hypotenuse is how much? It's adjacent is here. Opposite is here. Now, similar to the previous one, I can cancel out A and A. Same thing. What is remaining is numerator, root 3 by 2 is remaining. Denominator, only 1 is remaining. You can ignore the 1. So we will have how much? What about 1030? It's opposite by adjacent, isn't it? Opposite is this one. Adjacent is this one. So you divide them. BD divided by AD. BD is how much? BD is A by 2 divided by AD is how much? Root 3 by 2. Again, A and A can be cancelled out. Look at 2 here. 2 is denominator in both cases, right? When I look above, this is the denominator. Here also, this is the denominator. So I can cancel out the 2 also. Anything remaining from numerator? Nothing, just 1. What about the denominator? Root 3 is remaining. So sine 30 is how much? 1 by 2. Cos 30 is root 3 by 2. Tan 30 is 1 by root 3. You take reciprocal for sine, we will get cosec, right? Cosec 30 will be take reciprocal of sine 30, we will get 2 by 1, which is 2. So cos 30, take reciprocal, we are going to get sec 30 degree. We are going to get 2 by root 3. You just turn it upside down. What about tan 30? The reciprocal is cot 30. So we will get root 3 by 1. Turn it upside down. That's it. Okay, and then I'm giving you as assignment, you find out what is the value of sine 60, what is the value of cos 60, what is the value of tan 60. Very simple. What you have to do is I'm giving you the hint also. Look at this. Where is 60 degree? Right here, isn't it? So which one is the opposite? This one is the opposite. And which one is the adjacent? This one is the adjacent. So you redraw the triangle, but you shift adjacent here. You shift the opposite here. If you can do, I can do it again tomorrow. But you better write it down as assignment. You find out sine 60, cos 60, and tan 60 as practice for tomorrow.